I am Aparna Kedari and I am working as assistant professor in Department of Chemistry, Sarhad College of Art, Commerce and Science. In this semester, we have organic chemistry for your syllabus, and the first chapter is the fundamentals of organic chemistry. Let's start with fundamentals of organic chemistry. Then first is the inductive effect. What is inductive effect? The polarization is induced in the adjacent bond due to the polarization present in one bond. It's called inductive effect. In this, for example, in this example, CH2Cl, that is, this chlorine is more electronegative than carbon, therefore it has tendency, it is more electronegative, therefore it has tendency to withdraw or pull this bonding pair of electron towards itself, therefore it acquires slight negative charge and carbon acquires slight positive charge. Therefore, there is polarization in this bond, and the polarization is induced in adjacent bond due to the polarization present in one bond is called inductive effect. Polarization is present in this bond, therefore this polarization is induced in adjacent bond. Therefore, this is the inductive effect. Then covalent bond between two different atoms. This is covalent bond, and in this there is for example also HCl, HBr, CH3Br. The bonding electron pair is not equally shared because there is electronegativity difference between two bonded atoms, covalently bonded atoms. For example, here HCl, HBr, CH3Br. In this chlorine, bromine, and this bromine has more electronegativity than the hydrogen and carbon. Therefore, they has tendency to withdraw both bond or pull this bonding electron pair more towards itself. Therefore, they acquire slight negative charge, and the hydrogen and carbon acquire slight positive plus charge or positive charge. Therefore, there is polarization present in these bonds, covalent bond, because there is electronegativity difference. And the inductive effect is the polarization is induced in the adjacent bond due to the polarization present in one bond. Then important features of inductive effect. The inductive effect is permanent polarization in the ground state of molecule. It is permanent polarization and it is present even in the ground state of the molecule, and is developed due to the heteroatomic covalent bonds in the molecule. It is associated with the sigma bonds connecting two dissimilar atoms. That is, it is associated with or it is present in sigma bonds connecting two dissimilar atoms or groups. Then the magnitude of inductive effect is very small. Its magnitude is very small. It goes on decreasing with increasing distance from the polar atoms. For this, there is an example. This polarization present in this bond and this magnitude of this inductivity effect goes on decreasing as distance from this atoms increases. Then next is the types of inductive effect. Depending upon the direction of the pooling of electrons, the inductive effect is classified into two groups. First inductive effect is the electron donating inductive effect, and it is denoted by plus I effect. And second one is the electron withdrawing inductive effect, and it is denoted by minus I effect. Then definitions for these two types of inductive effect is: first, electron donating inductive effect. What is electron donating inductive effect? It is denoted by plus I effect, and it is the atoms or groups of atoms when increase the electron density around the carbon atom the effect is said to be plus I effect. Or the groups which have negative charge have positive than the neutral atom. That is, the atoms or groups which increase the electron density means they donate the electron pairs or they donate electron pairs to the or electrons to the carbon, that is, or they increase the electron density around the carbon atom, then this effect is said to be plus I effect. Then for example, first, the groups which have negative charge have higher plus I effect, that is more electron donating inductive effect, because there is more electrons when there is negatively charged atom. For example, here RCH2O minus and here neutral RCH2OH. Here the oxygen is neutral. Therefore, here negatively charged. Extra 2 electrons are present on this oxygen along with its lone pair. Therefore, it has more plus I effect. It increases more electron density around carbon than the neutral oxygen because it has its own only on its electron pairs. Then second, as electronegativity of atom decreases, the plus I effect increases. That is, here the magnesium and bromine is attached to carbon. Then the electronegativity. Boron is more electronegative than magnesium. Magnesium is more electropositive. Therefore, it increases the electron density around, more electron density around carbon than the boron. Therefore, here magnesium shows more plus I effect and boron shows less plus I effect. Then next is the generally the number of alkyl groups increases, the plus I effect increases. As number of alkyl, because all alkyl groups exert plus I effect, they shows plus I effect, that is they increase the electron density around carbon atom, therefore they exert plus I effect, that is electron donating inductive effect. Here in tertiary group, or when there is 3 carbon atoms, it increases electron density. Each alkyl group donates electron or increase the electron density around carbon. In secondary carbocation, for example, these are carbocations, and in secondary carbocation there are 2 alkyl groups. There are 2 alkyl groups which increase the electron density around carbon. In primary carbocation there is only 1 R group which increase the electron density around carbon atom, and in methyl carbocation there is no R group. Therefore, and as the number of R group increases on carbon atom, the plus I effect or magnitude of plus I effect increases. There is more electron density on this tertiary carbocation than the secondary, primary and methyl carbocation. Then next is the as percentage of S character increases, the plus I effect decreases, because as the percentage of S character increases, the electronegativity of atom increases and therefore the plus I effect decreases. Then examples of the electron donating inductive effect are the O minus, COO minus, that is carboxyl cation. Then next is the CH3 tertiary butyl group, then CH3 CH3 then next is deuterium, hydrogen, correct, all exert the plus I effect, but here magnitude of these two groups are very small. Then the next is the electron withdrawing inductive effect, that is minus I effect. Groups which have plus I effect have more minus I effect than the neutral. First, the definition for electron withdrawing inductive effect, that is minus I effect. The groups or atoms which decrease the electron density around carbon atom are called the electron withdrawing inductive group, or this group shows the electron withdrawing inductive effect, that is minus I effect. Groups which have plus charge have more minus I effect than the neutral atoms. Then, for example, the RCH2NH3 plus. Here nitrogen is positively charged. Then in second case, this nitrogen is neutral, that is with its electron pair. Then here this nitrogen is positively charged. It is electron deficient. Therefore, it pulls electron from this carbon. Therefore, it exerts minus I effect. Here also the electronegativity of nitrogen is greater than the carbon, but it has less minus I effect than this plus charged nitrogen, because here electron density is greater than this. Therefore, it exerts minus I effect, but it is less than the positively charged NH3 plus. Then as electronegativity of atom increases, the minus I effect increases. Therefore, for example, RCH2F and RCH2I. In this case, the fluorine and iodine are halogens, and the electronegativity increases down the group. That is, fluorine is more electronegative than chlorine, chlorine is more electronegative than bromine, bromine is more electronegative than iodine. Therefore, chlorine have highest electronegativity, and in comparison with this, the fluorine exert minus I effect. Therefore, in this case there is greater minus I effect than iodine, because iodine is less electronegative. It exerts minus I effect, but it has less minus I effect than fluorine. Then number of electronegative atoms or groups which increase the minus I effect. All halogens exert minus I effect or any other groups which exert minus I effect, and if these groups increases on carbon atom, then the effect of or magnitude of this minus I effect goes on increasing. For example, here chlorine. Chlorine here only in this is only one chlorine, that is primary halide. Here secondary halide. In secondary alkyl halide there are two alkyl groups, and this is tertiary alkyl halide. In this there are three chlorine atoms, here two chlorine atoms. As the number of electron withdrawing group increases, the minus I or magnitude of minus I effect increases. Therefore, in this case, in tertiary alkyl halide there is greater minus I effect than secondary alkyl halide than primary alkyl halide. Then next, as the percentage of S character increases, the minus I effect increases. Uh, that is, the this carbon become or the atom becomes more electronegative as percentage of S character increases. Here are some examples for the groups which exert minus I effect, that is Nr3 plus, NO2, cyanides, carboxylic group, fluorine, chlorine, bromine, that is all halogens, iodine, OH group and phenyl group, all exert minus I effect. Then next effect is the resonance effect.